Good morning children, welcome back. In the previous video, we have seen about the various forms of energy. And in this video, we are going to see about the two basic types of energy. That is the kinetic energy and the potential energy. It is denoted by Ke and the potential energy is denoted by the Pe. Okay, so what is kinetic energy? The energy of motion. Okay, everything in the motion indicates the kinetic energy. You can see over here the fan moving at the back of me, correct? So that it contains the kinetic energy, correct? I am speaking to you, that is also a kinetic energy. But what I am thinking in the brain, that is known as potential energy. That is the energy of an object's position or the stored energy. The key words you have to remember over here, that is kinetic energy is related to motion and potential energy is related to the stored energy. Okay, it is a stored energy. Okay, so one by one we are going to see. That is the first, kinetic energy. The kinetic energy is the energy due to motion. The formula you can see here is Ke is equal to half mv square, where m is equal to mass and v is equal to velocity, and the SI unit is joule. Okay, see the picture over there, a car is running on a road. Okay, when the car moves, the what is increasing, the velocity is increasing in the direction of the force, and the mass is given, that is the mass m. Okay, so that is the kinetic energy. Why? Because the car is in the motion. Okay, so we can see over here the derivation of the kinetic energy, how the derivation is half mv square, how it is derived. Okay, so work done, we have seen the formula first. Okay, it is work done is W is equal to F into S. Now let the acceleration produced after applying force on an object be A. Okay, acceleration will come in the action. Why? Because the object is moving now, so there is a displacement over there, so the acceleration came. Okay, he said the motion, the object is in motion, so why I will go back? There is the acceleration must be there, so acceleration came now. So where there is acceleration, there is a third equation of motion, you have studied it earlier. Okay, that is v square minus u square is equal to 2as. That is the third equation of motion. Now what we are doing, we are keeping the s as it is. Okay, we are keeping the s as it is, that is at the right side. Then what we are going to do, you have to just move 2a in the opposite side. What will happen then? V square minus u square upon 2a is equal to s. Okay, you can give this the equation as second equation. W is equal to F into S is your first equation. Now force, what is the formula of force? F is equal to mass into acceleration, correct? Now substituting F and S from equation 2 and 3 in the equation 1. Now what we are going to do, we are going to take the equation 1, W is equal to F into S, and what you are going to substitute, instead of F you are going to write m, mass into acceleration, and instead of S you are going to write v square minus u square upon 2a. Okay, in this there's a will get cancelled. Okay, then what will remain over there? Then W is equal to, okay, so here u also is going to cancel. Why? Because the object is going to start, correct? The object is going to start, it is going to be in the motion, so initial velocity will be 0. That's why u is equal to 0. So v square minus 0 will be v square. That's why u square also got cancelled. Okay, a also got cancelled. Okay, see over here, the a got cancelled over here, the a got cancelled over here, then the u square got cancelled over here. So what remained? M and v square remained. But the, what we can say, it is 2 also remained over here, correct? A got cancelled, but 2 is remaining over here. 2 means what? 2 is in the denominator, means what? It is 1 upon 2. Correct? So the W is equal to half mv square. So did you get now how, where, from where the half is equal to the W is equal to half mv square came? Okay, u square gone because it is the initial velocity, and initial any okay, I'll explain the concept of initial velocity now. See, again I am keeping this bottle over here. Okay, now what I am doing, I want to lift it. Okay, I am going to lift it. Before lifting, is there any velocity taking place? No. So this is called initial velocity, that is u. So initial velocity is 0. Now when I am taking this to a certain height, then what is happening now? It is v, that is the final velocity. Okay, so before lifting it or before the work is done, the initial velocity is always 0. That's why u is equal to 0. Okay, but now work done on object is equal to change in kinetic energy of object, and therefore you can replace that W by the kinetic energy, that is EK. Okay, that is energy, kinetic energy, change in kinetic energy of object. Therefore EK is equal to half mv square. You have just replaced W, work done, by the kinetic energy sign. Okay, nothing complicated over here in this derivation. You have to just remember some few what you can say formulas. Okay, firstly you have to remember the work done formula, that is W is equal to F into S. Then you have to remember the third equation of motion, that is v square minus u square is equal to 2as. Now we want that equation in terms of displacement, therefore we are going to keep s as it is, and you have to shift that 2a down, so it will become in the what we can say in the terms of displacement. Then you have to remember the formula of F is equal to ma, that is force, and then you have to substitute that, you have to take again the equation 1 and you have to substitute the values of F and S in that equation of 1. Then you have to cancel that a, u square will become 0 because of the initial velocity, and you get the formula Ek is equal to half mv square. You just try to write this derivation 2 to 3 times. You'll learn this very efficiently. Okay, there's nothing to learn in that, but you'll remember it immediately if you write down this 2 to 3 times. Okay, the key formulas you have to remember is the work done, the third equation of motion, and the formula of force, that is F is equal to ma. Only 3 formulas you have to remember in this kinetic energy derivation. Okay children, next we are going to turn over to the potential energy. The potential energy is the energy possessed by an object due to its position or state, that is it is a stored energy. You have to remember the potential energy is a stored energy. Sometimes when you are going to a interview or going for a anything where there's a quiz competition or anything, so some people ask you what is your potential. What is your potential means what, at what capacity you can work for them. Correct? So that is known as potential, that is a stored energy in you. So it is a potential energy. Formula is Pe is equal to mg h. Okay, you can see the picture over there, the cat is on the tree. Okay, so she is having a potential energy, correct, stored in her. So m is equal to mass, g is equal to gravitational acceleration, and the height h is equal to height. The cat has a potential energy at the high position. Okay, the SI unit is joule. See, now we have the derivation of potential energy. Okay, what we are having now, the object is lifted to a height h, that is h. Okay, let force applied on the object be F, let the mass of the object be m, let the acceleration due to gravity be g. Okay, so what is now happening, the object has gone to a height, certain height, so that's why the work is done over there. So potential energy is equal to work done. But what is the formula of work done? work done is equal to F into S, force into displacement. But now here, now we don't have to apply the third equation of motion. Here the displacement is done in the vertical manner, correct? The cat has gone upwards, it is happening towards a certain height, so displacement is equal to S, that is S is equal to H is given, height is given, and therefore the potential energy is equal to F into H will become. But now force is equal to M into G, correct? Mass into your gravitation. So that's why substituting now force is equal to mg in the first equation, and therefore it becomes the potential energy is equal to, you have to substitute m into g instead of f, and h will remain the same, and you get the derivation Pe is equal to mg h. This is the very simplest derivation in this chapter, okay, the potential energy derivation. You have to just remember the work done formula, then you have to remember the force formula, simple, okay. You just have to the tricky thing here is you have to remember the substituting thing, okay, where you have to change the s, where you have to change the mg, okay. So next we are going to see about the principle of conservation of energy, okay. Conservation of energy means what? You have the various forms of energy, so you will start thinking that so many energies are there in this universe. So many energies means how much energy will be there in this universe, correct? No, it is wrong, okay. The total form of energy or the total amount of energy in this universe is always constant, okay. So what is the principle of conservative of energy? That is, energy cannot be created and cannot be destroyed. Energy can change from one form to another form, and in this way the total of the energy is constant. This is the principle of conservation of energy, okay, or the law, the conservation of energy law, the law of conservative energy, okay. You have to remember this, that is, energy can neither be destroyed, neither be created nor be destroyed, but it can be changed from one form to the another form, and the total of the energy in this universe remains constant, okay. You have to remember the principle of conservation energy. See the example over here, it is given how it cannot be generated or it cannot be destroyed. You can see over there what you can say, a tof, okay, in Marathi you call it a tof. If you fire those gun, okay, so what is happening over there? First there is a chemical energy stored in that bullets, okay. The you can say the chemical energy then gets converted into the kinetic energy and the potential energy which was stored before when it is fired. Then the kinetic energy becomes less, and the potential energy becomes high, and then it is converted into the heat energy. Heat energy again converts it into the kinetic energy, and then it is exploded, okay. So again the kinetic energy, the chemical energy is converted into the kinetic energy is converted into potential energy is converted into heat energy, and heat energy is again converted into the kinetic energy, okay. So what happened here? The energy was not at all created, not at all destroyed, it was just transferred from one form to the another form, okay. So now we have covered about the energy, what is kinetic energy, what is the potential energy. We have derived both the equations, we have seen the conservation law, and now we are going to see in what way we have the power, okay. So what is power? Power is defined as ability to do work. We say na, what power you are having, okay. What is your power of the body? Is it strong or is it fast or is it very weak, okay. So what is power? It is the ability to do work. The SI unit is watt, and the formula is power is equal to work upon time, that is W upon T. And the power formula you can also is that work done, the formula of work done is force into displacement, and the displacement upon time is also velocity. Therefore, see over here, firstly what they did, they give the power is equal to work upon time. Okay, then what they did, they substituted the work formula here, force into displacement, and then what they did, they substituted the displacement upon time and gave the name as velocity. Okay, so final formula was power is equal to force into velocity. Okay, you can see over here the, I think that is a player, rugby player. Okay, the power of the body, that is strong and fast, big force or the small times. Okay, so the rate of doing work, that is power. Power is a rate of doing work, how much fast, how much slow. Okay, if work is done in time t, then power is equal to work done upon time taken. The unit of power is watt. 1 watt is a power of an agent which does work at the rate of 1 joule per second. Joule is a unit of force, correct, or the unit of work done, and that's why 1 watt is equal to 1 joule per second, or the 1 kilowatt is equal to 1000 watts. 1 kilowatt is equal to 1000 watts or joule per second. Okay, here the conversions are given over there. See over here, the commercial unit of power, that is what energy, what the electrical energy is used in your house or the industries is expressed in the kilowatt, correct. Today's homework, you can say that you have to observe your electrical bill today. Okay, take from your parents the electrical bill and just notice or just mark whatever the kilowatts is given over there. Okay, so the commercial unit of energy is kilowatt. The kilowatt hour is the energy used in 1 hour at the rate of 1 kilowatt, and 1 kilowatt hour is equal to what you are doing, 1 kilowatt into 1 hour. Okay, so what is 1 kilowatt? 1000 watt. And what is 1 hour? 3600 seconds. We are going to multiply it. What we are going to get? 3.6 into 10 raised to minus 6 joule. Okay, so 1 kilowatt hour is equal to 3.6 into 10 raised to minus 6 joule, and this is the commercial unit of power. Okay, so electrical energy used in homes and industries are expressed in kilowatt hour. The electrical energy used during a month is expressed in units. So here 1 unit means 1 kilowatt hour. Okay, so you can see over there the units are given over there, 1 unit, 2 unit, 3 units. So 1 unit means 1 kilowatt hour is present. So if you have 3 units, then there is a consumption of 3 kilowatts 3 kilowatt hour. Okay children, so here we have completed our lesson, that is work and the energy. So it is very applicable lesson we have seen over there in daily life. When you walk, when you sit, in the back of your mind some questions must come in your mind, that is, now what energy I am consuming, now what energy is expressed, I am talking, now what energy is expressed now. Okay, so in learning these chapters you have to play these movies, or you can say play these slides in your back of the mind. When you do the work, you have to just see, when you lift something, you must think of that, is the work done here now, is it against the gravitational, it is against the force, it is in the direction of force, so what will be the sign, the positive or the negative. Okay, so such things should come in your mind, and then only you will learn these chapters very efficiently. Okay children, I am repeating again and again. For the gravitation lesson also I have repeated, and for this lesson also again I am repeating. Don't study it for the exam sake or the paper sake, or what we can say about because I am telling you don't learn. Okay, you learn it because you are experiencing these things in your day-to-day life. Okay, so enjoy these lessons by experiencing it in your everyday life. Okay children, I'll not take your much time. You have to read this lesson very carefully, write down the derivations 2 to 3 times so that you can remember. These derivations are very very easy. When you get the derivations, you will learn the formulas very easily, and when you remember the formulas, you are going to solve the numericals very easily. Okay, don't have the phobia of that numericals. Okay, the numericals are very easy when you are cleared with your concepts of the derivations. Okay children, we'll practice those numericals also, but for now you have to read the lesson and practice the derivations very effective, very efficiently. Okay, do not fool me or do not fool yourself. Study very sincerely with these derivations. Okay, thank you children.